Let's first look at the case of sine x equals to 5. Now, that should be relatively easy to do because we should remember that sine is the function that changes between -1 and 1. Same as cosine, actually. So if somebody asks you a question, when sine x equals to 5, the answer is never. Well, as long as you're dealing with real numbers. Okay? So next question is when sine x equals to 1. Alright, so let's just draw our favorite unit circle. And sine is the vertical coordinate of a point on a unit circle. The only point on a unit circle that has a vertical coordinate of 1 is the point A, this at the very top. And that corresponds to an angle of 90 degrees or pi over 2. Alright? So we can write x equals to pi over 2. Should we stop here? Well, what if I want to be at pi over 2 and then I want to go around another circle? So now my angle is actually pi over 2 plus 2 pi. But I'm going to get to the same point A where I was before. And that point A has vertical coordinate of 1. So obviously, if x is pi over 2 plus 2 pi, sine is still 1. What if I do another circle? I get 4 pi. Well, again, I'm getting to the same point. Sine is still 1. Now, what if instead of going counterclockwise, I want to go clockwise? So I do this, I go to pi over 2, I get to point A, and then I decided to go clockwise, one full circle. I get to the same point A, so sine is the same. So pi over 2 minus 2 pi should give me the same answer, right? Sine of that is going to be 1. What if I do two circles? Same story. It's pi over 2 minus 4 pi, also give me sine equals to 1. So now I guess you probably get the story. So if I take pi over 2, if I'm at point A, and notice add or subtract any number of 2 pi's, okay, I'm going to get to the same point, and I'm still going to have sine equals to 1. So the final answer would be written as pi over 2, x equal to pi over 2 plus 2 pi n, where n is any integer. 0, plus 1, minus 1, plus 2, minus 2, and so on. Now there's a short notation for this thing. So if I don't want to write this thing as a equals 0, comma, plus minus 1, comma, plus minus 2, comma, and so on, I can write n equals to z, and this is well-known notation. The z, the strange-looking z, is a symbol for the set of integers. So it simply means that n is any integer. All right, let's look at cosine x equals to 0. Well, you can kind of think about, am I not getting the same answer as sine x equals to 1? Well, sine x equal to 1, cosine x equal to 0. Wouldn't I get the same thing? Well, let's look at it. Well, actually, cosine x equals to 0 is not the same as sine equals to 1. Because for sine x equal to 1, we're only getting this point A in the top, that is satisfied. For cosine x equals to 0, there are 2 points. One, the same point A as before, but there's also a point at the bottom, B. So the very top and the very bottom points gives me cosine x equals to 0. So it's a sine x equal to 1 on the top and sine x equals to minus 1 at the bottom. The top one corresponds to angle pi over 2. The bottom, if you go down, we get again pi over 2, but in negative direction, so it's minus pi over 2. And again, as before, if I had to subtract any number of loops, I had to subtract any number of 2 pi's to both of them, to either pi over 2 or 2 minus pi over 2, I get to the same point where I started. So one pair of solution is plus pi over 2 and minus pi over 2, but then we can get any number of 2 pi's and also get the solution. So the general solution is like this: x equals plus minus pi over 2 plus 2 pi n. Again, plus minus should be treated as either plus or minus. Either way, we get a solution. Or if you don't like plus minus, you can write them separately. You can have x equals pi over 2 plus 2 pi n, and x equals to pi minus pi over 2 plus 2 pi n. All right. Next problem, we want to look at cosine x equal to 1/2. Now, again, we draw our unit circle. Cosine is the horizontal coordinate. So on horizontal coordinate, we find a point 0.5. It's right here in the middle. Now, from that point, we draw a vertical line until it intersects with the unit circle. We get 2 points A and B, one on the top, another on the bottom. It corresponds to 2 angles. One is this ADC, the other BDC. Okay? And we know from considering triangles, right triangles, that cosine x equal to 1/2, one of those angles. If you have a right triangle, the angle of 60 degrees, or pi over 3. And that's going to be the angle on the top. Now the angle on the bottom is really, what you have on the bottom in general is the mirror image of what you have on the top. If you take this point A and reflect it over this horizontal axis, you get point B. So the angle down is also going to be pi over 3, but now we're going in negative direction. We get minus pi over 3. But those two triangles, ADC and BDC, are congruent. One is a reflection of the other one. Now this is just for completeness. I'm showing that if I look at the point A, where horizontal coordinate is 1/2, vertical coordinate or sine of this angle would be square root of 3 over 2. For the bottom one, it's square root of 3 over 2, but with the minus sign. Okay. But for us, what we can say, well, we have 2 axes, 2 points A and B. Point A correspond to angles pi over 3 plus 2 pi n, and point B correspond to points minus pi over 3 plus 2 pi n. All right, that's the final answer. Now let's look at sine x equals to 1/2. Drawing our circle. Sine is the vertical coordinate, so we're looking for 0.5 on the vertical coordinate, on the vertical axis. Now we draw a horizontal line and it intersects our circle in 2 points, points A and B. These points correspond to such 2 angles. Now remember our geometry. We know that when sine x equals to 1/2 and we have a right triangle, the angle is 30 degrees, or pi over 6. That's the angle pi over 6. Now here we also have a symmetry, but it's a vertical symmetry. So point B is a mirror image of point B if we take if you look at the symmetry of a vertical axis. And because of that, if this angle here is pi over 6, in this case, this angle is going to be pi over 6. But when we're counting x, we're counting from this direction, from this line, and we're going like this. So, and if we're going like this, the angle will be what? Going to be pi minus this pi over 6, and that is 5 pi over 6. So 2 options, pi over 6. Well, okay, I'm finishing all the coordinates. But now we have 2 options, either pi over 6, it's point A, plus 2 pi n, or point B, 5 pi over 6 plus 2 pi n. And that's it.